So today we are going to talk about the equivalent system. What is the equivalent system means? Here for this problem we had a lot of loads and a moment. So what we are trying to do is trying to simplify the whole system to one load and a distance. So for the first problem here, we need to simplify this with one load and measured from end C. So what does this mean? It means that we're probably going to have a load here, and we need to figure out how much is this load and where it should be placed in the whole system. So the first step is trying to find out the equivalent resultant force. So we can see we had 3 forces here in this system, so it will be better to add the force in the x direction and y direction, and then we try to find out the total resultant force. You can see for the 250, the x component is in the negative direction, so that's why you have to put a negative sign. So eventually we had a negative value. What does this mean? It means that the x components of the total resultant force actually go to the left. And then if we say go up, will be positive. And we can try to summarize all the forces in the y direction. Again, we had a negative value, which means the y component is also going down. So we can try to calculate the magnitude of the total resultant force. And then for this force, we also need to identify which direction that is going to be. So finally, we had 63 degrees. So what does 63 degree means? It means that our total resultant force will go this way, and the angle is 63 degrees. Or what you can do is based on the force components, x components and y components, you can decide the total resultant force direction. So which means we already solved the first question mark, 991 Newton. So the next step is trying to identify where we are going to place this total resultant force so that the first original system and the second system we were trying to draw is going to be equivalent, which means they are going to be equal. So what we are going to do is always think about what is the equivalent means. It means that the moment in the equivalent system will be equals to the moment in the original system. So which means for now we need to try to find out measured from C. So if we summarize moment at C for the original system and the new system here, these two moments should be equal. So now let's take a look. For the new system, if we try to summarize the moment around C, only y components going to contribute the moment. So let's try to multiply the question mark. And that's a moment in the new system. And remember, it will equals to the moment in the old system here. So what we were trying to do is try to summarize all the moment around C by the original moment and created by all the forces here. And here, we are going to assume going counterclockwise will be positive. So we had 400, and for 300 Newton, it will create a clockwise moment. So that's why it's negative. For the 250 Newton, only y components going to create moment. However, for the 500, based on the dimension, you can see both x and y component going to create moment. So in this equation, you can see there's only one unknown force, unknown distance. So which means we can solve the distance here is going to be, so which means we can identify the location here is going to be 2.64 meters. So now let's take a look at the second problem. Replace the frame by a single resultant force specified measured from end A. So what does this mean is we're actually going to apply our total resultant force, 991 Newton here. And what we have to do is try to identify where is it. So let's say double question mark. So what we are going to do is always going to use the moment in the original system will be equals to the moment in the equivalent system. So now the question is, can we use the moment we calculated before for the 2,000 and 3,300 in the previous problem? The answer is no. Why? Let's take a look at here. What we have to set up the equation is going to be original equals to the equivalent. However, this time, the moment location actually changed to the location A, and this is why we will not be able to use the previous calculation. What we have to do is trying to calculate moment around A. You have to start a new calculation. So now let's take a look. If we try to resolve the force in the x and y direction, you can see this time force in the x direction is going to create moment around A, and the y components actually contribute nothing. So which means our moment function is going to be, for the equivalent system, will be fx times the double question mark, and it will equals to the moment for the old system by all the forces here. And make sure you are going to include the applied moment, because we will try to summarize the moment for this situation. And again, we were trying to say going counterclockwise will be positive. So we had 400, and then for the 500 Newton, only x components going to create moment around A. And here, be very careful about the new lever arm, because your moment location is changed. And then you can see, respect to A, the 300 is actually create a clockwise moment. So that's why it will be negative. And again, what we have to notice that the x components of 250 and y components, both of them are going to create moment. However, for the y component of 250, it's actually going to create a clockwise moment. So that's why it's negative. However, for the x component, you can see, respect to A, it's actually create a counterclockwise moment. So watch the sign whenever you summarize the moment. Okay, again, take a look at the whole equation. We only had one unknown thing, the distance. So which means we should be able to solve this distance. And again, we have to use fx, not fy, in the calculation. So it will be 1.78 meters.